Okay, I think we are streaming and we can go live. So welcome everyone. So I hope you're having a wonderful March afternoon here in Boston. It's the second day wherein we have gone over 50 degrees. Yesterday I was able to squeeze in a quick run, and I'm kind of seeing outside my window. It's already thawing, and I'm really looking forward to go out after this session. I hope you're all staying warm and safe and looking forward to the reopening. I'm kind of watching the news as the vaccine has been given to a lot more people. There's been huge enthusiasm, and I presume the enthusiasm is reflected in the stock markets. What a volatile ride we've been having the last few days. I hope you're kind of watching all the new trends and kind of gearing up for the spring. So today's session, I have been doing some work in the context of algorithmic auditing, and I thought I'll share some of the work we've been doing here at Quant University, and also get a little bit of insights from you all, from what you've been seeing in the field. So I'll kind of take the first 30 to 40 minutes to present like what algorithmic audit is all about, and I'll talk a little bit about one of the classes we have recently put together, and we are delivering it with our partner, the Premier organization. And I'm also going to show some case studies which we've been working on. And I'd love to get your thoughts and feedback on whether this is something you've been seeing in the industry too, or does it gel in the context of what you've been working with in the context of machine learning models. So let's get started. One second, I'm gonna bring up my slides. Zoom tries to hide all the windows, so I'm just trying to figure out how I can enable the screen share. Okay, so I think you should be able to see my screen. So this is again the Quant University Winter School session. We've been doing multiple courses in the context of machine learning, artificial intelligence, and quantitative finance. And we've seen a lot of interesting applications and interesting work which our participants are doing over the last few months. And as most of you know, I've been working in the context of machine learning, data science, and finance for many years now. And one of the things we've been trying to do here at Quant University is to kind of bring in the disciplines of data science, machine learning, and quant finance, and see how you can make it practical for people who have been adopting these techniques in the industry. And we have put together multiple programs to encourage people to upskill themselves, to basically not only look at the world in the context of research papers and all the cool things which are happening in the industry, but also to see how these could be pragmatically applied in your day-to-day work. And many of the courses we have been offering here at Quant University are geared towards professionals, so that you have real-world case studies and you can apply them in the context of whatever applications you've been building. So we have had partnerships with multiple organizations, and recently we have built in multiple partnerships with Premier, and we've been offering courses to the Premier membership and also to others. And we've had people from 13 different countries who have taken our courses as a part of the various schools we have offered. We started offering the summer school, which was extremely popular, and then we went to the fall school. And now we are going through the winter school, and we are almost at the end of the winter school, and we are gearing up for the spring school. And when you come to the spring school, you have multiple courses. And the theme of today is algorithmic auditing, and I'll share some of the materials from what you will see in the algorithmic auditing course. But in addition to that, the Just Enough Python for Data Science course, the Machine Learning course, and the Model Risk Management course, wherein we have had multiple students take these courses over the last 6 months. So these are made on demand, and it's readily available on the Premier website. So you can enroll whenever you want and go through the course material. We have built in a lot of functionality within Q.Academy, which is the platform through which we are delivering all these courses. And that'll enable you to start and stop whenever you want, and also to practice your exercises on the cloud. And you don't have to do any installs. Everything runs on the browser, and you should be able to go through all the exercises. The two new courses we are offering, one is the Algorithmic Auditing course, which you're going to be seeing a part of it in today's session. But this is a rigorous course. It's a 6-week course we have put together, and it's starting late in the month. And you should be able to kind of understand the core principles of how the algorithmic auditing profession is growing, and then what all does it take to audit a machine learning model. In addition to that, we are extremely proud and happy to announce the risk and ML models, stress testing, scenario testing, and evaluation course. So this is primarily geared towards people who have been building machine learning models, but now want to bring in the aspects of what does it take to build a robust machine learning model? How do you do stress testing, scenario testing for machine learning models? What evaluation metrics do you use? How do you monitor these models? And how do you take care of drift and various other aspects, which are extremely important as you go towards machine learning in production? So I hope many of you are going to join us in these courses, and I look forward to having you. So for today, let's kind of get to the core things we want to talk about. I want to briefly give you like a 60,000-foot view on why algorithmic auditing is becoming extremely important in the industry. And I'll kind of define algorithmic auditing from what we are seeing from a practitioner's perspective here at Quant University as we go and do third-party model validation and other activities for various clients. I'll touch base on some of the themes on what you'll have to figure out when you're talking about auditing a model. And I'll show you a couple of examples on some of the things you could potentially look at. And I'll primarily use open source tools. That way you're not constrained to an enterprise tool. We have multiple enterprises we work with, but for today's session, so that it's accessible, we'll primarily use many of the open source tools so that you can replicate many of these examples in your own settings. And I hope it's going to be something you can build upon as you and gain more knowledge about the field of algorithmic auditing. Okay, so let's get started. As many of you know, machine learning is becoming extremely popular in the financial services industry. And the field of machine learning, when I was a graduate student 20 years ago, was very nascent. And a lot of people were interested in the field. They allowed the research aspects of it, but the pragmatic aspects of it was very limited because we did not have the computational power. The algorithms weren't really structured well. We did not have the requisite hardware. So many a times these were ideas which we felt like, well, if things were different, we could have adopted it. But for now, let's stick with our core statistical models or simplistic decision-making process. Fast forward 15 to 20 years, we have seen a tremendous growth in different algorithmic architectures. Now with deep learning, machine learning, a lot of new innovations have happened in the last 5 to 10 years, more or less. And that has resulted in a significant increase in scientific publications addressed towards machine learning. In addition to that, we have seen a significant interest in the industry towards not only leveraging these machine learning practices, but building new IP. And a lot of companies are building patent portfolios on leveraging these machine learning models. So these were some charts I pulled out from the WIPO IPO website. And you can see areas like neural networks, support vector machines, rule learning, deep learning, these are growing areas, and a lot of companies are now increasing the amount of contributions towards building IP, but also, kind of fortifying their patent portfolios by building applications and then filing for patents. Now, as you all know, a lot of companies are now hiring in the context of machine learning and AI. And whenever you go to the website, like 15 years ago, when I was gearing up towards my first role in the financial industry, it was typically things like, statistical modeling, the knowledge of derivatives and various other aspects. But nowadays, if you go and look for a position in the banking industry, it's predominantly geared towards bringing in machine learning related talent. And that's obvious, right? Because a lot of things which are happening in the machine learning world has something to do with data, something to do with building algorithms, leveraging the awesome hardware architectures which are out there, which are either in the cloud or through hardware acceleration platforms like GPUs, FPGAs, etc. And also the skills have significantly changed. When people talk about building quantitative financial models, it was predominantly leveraging, things like derivative pricing or optimization methods or factor models. But nowadays, many of the applications in the machine learning context leverage things like deep learning, computer vision methodologies, sentiment analysis, natural language processing, and a lot of automation. A lot of things are built not just in the context of a single model, but you're building out entire pipelines to address various aspects of how do you build out different machine learning applications. So there's been a lot of research on what has the industry done, and I found this recent report, the Artificial Intelligence Index report. It's a very well put together report. So if you just Google Artificial Intelligence Index Report 2021, you can download. It's more than 150 pages. So I would definitely recommend you to take a look at this report. I found a couple of charts mentioned in this report very interesting. And the reason is, if you look at the aspects of risk in AI models, one of the things which was surveyed was risks from adopting AI within an organization that's considered relevant in 2020. Many of the respondents predominantly focused on cybersecurity, regulatory compliance. Explainability is getting more and more focused. But when you think about the discussion in the context of algorithmic auditing, there's been a lot of emphasis on fairness and equity and ethics. But as you can see, this is not that highly considered in the ranking. But many of these themes are predominantly of focus, which is regulatory compliance, explainability, etc. In addition to that, when you think about risks from adopting AI, that organizations are pragmatically taking steps to mitigate. And this is not just being aware of it, but taking actual action to mitigate in 2020. You still see these areas, but then you can see things like, equity and fairness, which, when you talk about algorithmic auditing, it becomes a huge issue when you do not have the right kinds of data sets. A lot of companies are still thinking that, it's probably in the 10 to 15% range of respondents are actually taking specific actions. So what does it all mean? So, there is what is called as an implementation gap. And this was recognized by multiple organizations. So if you do a little research on what's actually happening, and this was something I pulled out from the WEF, the World Economic Forum. They put out a new initiative called as GAIA. And one of the statements they make is there are 175 ethics-based frameworks which are out there. And that's been recently developed in the last few years. Many industry organizations, government organizations, civic societies have put together various frameworks. But unfortunately, many a times, these are not something which are practical. And even though there is concern growing, there is what's called as an implementation gap. And that's kind of reflected in the graphs I just showed you. Many people have not even kind of considered that as an important thing, either due to an awareness issue or just because there aren't pragmatic tools to make these aspects, something which you can integrate with your work practices. And that's an area we have tried to focus on, because what's the use of having a framework if no one can adopt it, right? So you want to integrate it with the tooling, with the right kinds of methodologies, so that you can actually integrate it with your work practices. And you can incrementally build and focus on the areas which are important for your organizations, contextualizing what's actually needed. But one thing I want to mention is, even though there's a lot of concern, the implementation gap is something we have to address as practitioners, engaging with various stakeholders. Otherwise, we'll have a lot of frameworks without much use. So I want to talk about a couple of things which have happened in the last few months. And so there was a bill which is proposed to regulate algorithms which are used for hiring. There's been a lot of concern on facial recognition software, and this was one of the bills which has been proposed. And the other one, this was a company called HireView. They actually dropped facial monitoring, and they did an algorithmic audit. And they said, well, this is based on the recommendations, we're going to be dropping facial monitoring. And the third one I kind of looked at was, there's a lot of interest in the context of third-party auditing. And this was something which, the company Pymetrics actually had a consulting engagement with a couple of researchers at Northeastern University, and had them review their algorithms, and they got like an external opinion on how their models are with respect to specific aspects like fairness, etc. So you're seeing a lot of efforts in the context of self-policing, some regulatory aspects, trying to see if algorithms need to be audited. But one of the things you got to consider is, the change which is happening is real, and the complexity is growing. In the past, when you talk about machine learning models, we've been just seeing the development of actual models. We had seen different frameworks for building out interesting models, but the complexity of this whole workflow is growing. As the ecosystem matures, as we've seen innovations in the context of cloud, in the context of automation, a lot of cloud providers, technology providers have started building infrastructure. And we are now seeing the maturity in the pipeline, wherein we have specific tools for data ingestion, specific tools for cleansing, specific tools for building out different models, monitoring different models, looking at aspects like explainability, and then also the deployment cycle. How do you measure drift? How do you monitor these? So the definition of the model has significantly evolved over time. It's no longer just the model which takes input, does some things, and generates outputs. Now you're kind of factoring in all the key aspects which go into the puzzle when you're starting to build out an entire model. And in addition to that, these are data-driven models. So the data governance and model governance are kind of coming together. And when you think about auditing a model, you have to contextualize what specific data sets were used to build these models, and how does it perform to the data sets which were used for training, but also for the test data sets which the model has never had seen when the model was being built. Okay, so let's kind of now talk a little bit about what is an algorithmic audit. Now, how can you kind of define an audit? And then I'm going to give you some examples on how we have seen certain things happen, and I'll open it up for discussion. Now, if you ask anybody, what's an algorithmic audit, I don't know how many of you know the story. It's an ancient Indian tale about how do you define an elephant. And if you have 6 blind people, blind men, ask about an elephant, they will have their own perspectives. And it's comical, but in some ways, the definition of the algorithmic audit is more or less something like this. Everybody has their own view on what should be defining or what should be prioritized in the context of an algorithmic audit. The way we have kind of looked at it is it's kind of building upon the model risk management principles, and it has to be incrementally adopted from the established practices we've already seen. So we kind of define it as a structured process conducted either internally or by a qualified independent third party. that involves verifying and or validating the working of the algorithm, along with the data, model, environment, process, contextual to the use cases in which the algorithm is supposed to be used. So that's one part of the algorithmic audit. And then identification of issues that are clearly articulated in scope for the algorithm. And this criteria could include bias, fairness, discrimination, explainability, interpretability, etc. And again, the key word here is context. You can't just generalize it saying that an algorithmic audit should focus on these aspects, but you have to contextualize on what is important and what needs to be audited. And then the documentation of the understanding of the algorithm's behavior, uses as observed and evaluated by a qualified individual, and the recommendations for mitigation, control, and elimination of noted risks. So this is kind of the way we have looked at the algorithmic auditing process. And this kind of goes with the many years I have audited models and monitored models for various entities. And machine learning is in some ways an incremental update to many of the quantitative models, at least in the financial services industry. Many other industries are seeing models as a new construct because people have been typically making decisions, and now those are being replaced by automation and machine learning models. The financial industry, in many ways, already has established best practices, and we are kind of seeing an incremental adoption of some of these methodologies for machine learning models. Now, I found this definition of an algorithmic auditor kind of amusing. Deloitte actually put out like a page wherein you have an entity which is responsible towards auditing different models and the kinds of skill sets they would need to have in order to build out the various models. So I want to kind of talk a little bit about like some of the things we need to look at when we are auditing a model, and then I will show you a Q-Sandbox demo of how we are looking at auditing different kinds of models. Some of the things we have to look at are, why did we have to first construct this algorithm? And how will this be used? And who or what will it affect? And these are important questions to answer. It's not about the technology. Many times when people talk about algorithms, they talk about as though it's just a scientific construct which has been built using various methodologies, TensorFlow, deep learning algorithms, GANs, et cetera. But the primary question you need to answer is like, why do we need to have a model or an algorithm in the first place? And is the usage going to be limited to a small group wherein you're either trying to automate certain things, wherein you have a base case that this is how things were done, and when we use this algorithm, this is how things are going to be affected, and then we can focus on this narrow use case? Or is it going to be having a larger effect? For example, if I'm going to be deploying a credit decision making algorithm, at that point, it's no longer just a small group of folks who are going to be affected. It's probably going to be an entire segment of the population who may be affected. And then the scope is going to be different. And you have to think about like, well, what data was used to train the model? And does it factor in many of the nuances which we hadn't seen in a specific setting? And how do we factor the distance of the various folks who may be affected? What are the aspects of diversity we have to factor in when you're building out the models and testing out the models when these are deployed in practice? But the second thing is it's all about the data, because many times people think that the algorithms need to be robust. But if you don't have high quality data, the algorithms can only do so much. For example, I'm actually working on a healthcare AI project where data is in silos and we have very limited data. And we are figuring out that with the limited amount of data, the algorithms aren't doing a good job. Even if we have significant amount of computational power and we are trying to do various things, it doesn't really matter very much if I do not have representative examples to train my models. So as a part of the algorithmic audit, you have to make sure that you really understand the data which was used to build up these models. And also, what data was used to test various aspects. And those could be things I've collected in the field, or it could be synthetic data. And you have to also make sure that not only is the volume enough, but is it okay to use these data sets for various aspects? And are they privacy-related concerns? Are we going to be impacting certain populations if we use the data sets in different ways? And what happens to the rare classes? What happens to the data sets we have not seen at all? So various aspects of domains have to be factored in when you're thinking about building out these kinds of models. And the third aspect, it kind of ties into my other course, which is the stress testing and scenario testing course. Many a times when we work with just real data sets, all the scenarios haven't really been played out. And that's something factoring when you're building out machine learning models. Just because it hasn't happened in the past doesn't mean that it's not going to happen in the future. And how will your model perform on scenarios which are plausible but has not been realized yet? Now, the machine learning model could generalize what it has seen in the past, but for scenarios in which you anticipate are possibilities, you have to make sure that those data sets are provided to the model, and we train the model to react for those kinds of scenarios. And that's extremely important, especially when you're building machine learning models. We have kind of looked at various ways in which we can address this problem, and some of the tools we've used in the context of synthetic data generation has been helpful. The one thing I want to kind of emphasize is, when you think about models, there is no real formula, and it's not possible to just prescribe that this is the model you should be using, this is the data set you should be using. It has to be contextually built and built by people who know what they're doing. And that's where you have to think about when you factor in the model audit. You have to understand what the modeling philosophy is. Is it a white box model or a black box model? How does it actually work? Do we really understand the model? When we have had multiple sessions on explainability and interpretability of machine learning models, we have to make sure that we really understand the models as we are building it, but also if we are expected to provide explanations to the end users or to the people who are going to be affected by the decisions of these models, we know and we have a robust infrastructure in order to do that. And then also, here's where the concerns of fairness and bias would come in. And that's something which has to be clearly articulated on who could potentially be affected and what does it mean in order to ensure that you are not only kind of ensuring the fairness in the model, but also looking at it from the perspective of responsible AI, as an entity which is going to be automating various decisions. How do we make sure that whatever decisions we are taking are responsible, but also factoring in the risk considerations on what in case there is a situation which we have not anticipated, and what could that potentially lead to if that was realized, and quantifying those metrics both in terms of model risk and also in uncertainty quantification methods. And this other thing I want to emphasize is, and many a times this notion of an environment kind of gets swept under the rug. And many people think that the deployment is a IT issue or a software issue which they don't have to think about from the model context. But guess what? We are living in a world wherein the enterprises which were building and supporting the software are not going to be there when most of the packages or most of the software we've been building on are on open source stacks. And we are trusting the community to do the right thing and build out the right kinds of tests and deploy these kinds of applications. But ultimately, it's our responsibility as organizations when we build things, even if we are sourcing it from an open source world, we have to make sure that everything works. And we have to test it in the right kinds of settings. And that's where an environment audit comes in to ensure that the execution of the models is something which is predictable. And we can replicate the experiments or the tests which we have conducted in a development setting, and we can go back and run the same kinds of setups. And that's where things like microservices and Docker would come into play, to make sure that you are creating reproducible environments so that you can test and audit various aspects of the puzzle. And then finally, this is something we have been looking at significantly in extending the definition of a model, because ultimately, if everything works in here well, but you haven't really factored in many other pieces of the puzzle, what that means is that you are trusting that everything else is okay, and only this is going to be something you have to govern. In the context of an algorithm to work well, it has to depend on the data, it has to depend on the various processes you have, both upstream and downstream. And that's where you have to factor in a pipeline audit. You have to make sure that the entire pipeline of how the data gets processed and how the models are built and evaluated and deployed are factored in as a part of this audit. I know some of these things I'm mentioning are probably things you have already looked at, but when you structure a model audit and algorithmic audit, you have to make sure that you are asking the right questions. And maybe there are other processes which have factored many of these things. And you may not have to build upon other processes. But one thing I want to emphasize is you have to consider and contextualize based on the various themes. Otherwise, you're going to be focusing only on certain components, and there are various aspects of risk which have not been addressed yet. So that's a little bit about what is algorithmic audit. So I'm going to give you a couple of demos now. If there are any questions, I can answer. And I think John had a question on, how is this different from a model validation? And in the context of model validation, we have certain regulatory frameworks like SR 11.7 in the financial services industry, which has governed what does it mean to build out various kinds of models and govern various kinds of models. Now, these algorithmic audits recently looked at when we are bringing in machine learning and AI related products, and the key aspects of explainability has significantly needs to be looked at, because these are really complex models. We're not just kind of leveraging simplistic techniques to build out models. And if we don't understand what these models are doing behind the scenes, then we are kind of building in a lot more risk. The other aspect is these are data-driven models, which means that it depends on what kind of data you're sourcing in and building out models. So the factoring of the aspects of data is another key consideration when you're building out these models. And the third one I would say is factoring in the diversity of the various data sets and ensuring that you're kind of comprehensively looking at various aspects as you build and test out the various models. So I would say you're building upon the framework of model risk and model validation. But algorithmic audits can go beyond that, and it could be auditing an algorithm as a service. It could be leveraging various aspects which may not, be in the purview of typical model risk management. If you have any questions, please feel free to type in the Q&A or the chat window. Otherwise, I'll kind of switch to the demo. And this is kind of the exciting piece, which we've been working on over the past couple months, focusing primarily on algorithmic audits. And for many of these things, we have kind of leveraged open source technology so that we can replicate and build upon things, but we're also building out various integrations. So we kind of envision, auditors and developers not only to be, building out models and testing it as a one-time process. We want it to be something wherein there is a seamless transition and the seamless aspect of how you're building models and how you're evaluating it, how you're validating it, and you're kind of incorporating that whole process as a part of your workflow as you're building out your models. And that's where, when we think about a project, on especially when you're building out models, and a project is kind of constitute, you have multiple experiments which are built out. So here we're kind of just taking a sample data set, which comes with the scikit-learn, which is a Python package, And it's a classification problem. So leveraging various measurements, we are kind of building a classifier which is going to determine whether a particular diagnosis of breast cancer is benign or malignant. Okay, so these are some of the key aspects of what you would want to look at. You want to have aspects of what number of experiments are you doing, and can I reproduce the entire experiment, and what were the outcomes of the experiment, and what are the summaries of the various experiments. And we're also big proponents of what's called as an audit checklist, and this is something you would want to build upon as you and again, so it's a contextual thing you want to build up. So that's why we are kind of creating a framework wherein you could actually build your own audit checklist depending on the kinds of applications you're going to be building. So for example, if this is an audit checklist for a particular case, so it could be for a report like this, I'm going to be focusing on data audit, model audit, an environment audit, pipeline audit, an explainability audit, a fairness and bias audit, and then what are the findings of all these aspects, and then what are the various recommendations. So this is my audit checklist, but we have created it so that depending on the use case, you could structure a different template, and based on the choice of the template, you can generate different reports. So and again, that's contextual to the project you're going to be working on. Now, the other key piece to the whole puzzle is to understand the various elements and kind of dive deep into each one of them. So what we did was we said, well, if I'm going to be looking at various aspects, and I'll just show you a sample piece of the code, which is and this is readily available, and you can run it on Google Colab. So this one leverages some of the frameworks which are out there. So we looked at a couple of different frameworks. IBM has some frameworks in the context of explainability and fairness, and then Google has ML Fairness Gem, and then Pymetrics has a package called Audit AI, and then there's FairLearn for fairness and bias, and for explainability, H2O has a framework, AX 360 is an available framework. There's a framework called Manifold. There's also the Interpret community framework. So you see a lot of different frameworks which are available out there. So you don't have to reinvent the wheel when you're trying to build out. And that's where we have built out this Q toolbox, which will enable you to try out various tools. And you don't have to install all of them because everything is running on the cloud, and you can readily access various aspects to it in here. And then we have also built a bunch of models which we could use to try out various things, either using TensorFlow or using some of the services on Azure, Google, etc. And then obviously there are various modeling components, and that's where you may have to connect to various sources. It could be, make it to MATLAB, or using R, or using NVIDIA Rapids. So there are a lot of modeling choices available. So that's where you have to start factoring in, like, where is my data again? And then how do I actually work with the data? So let me just illustrate one use case in here. So in the context of data, what we did was, well, we want to explore the data and understand the data. And in this particular case, it's a publicly available breast cancer data set. And there are packages available, and those could be easily used. And this is a tool or a package called as Pandas Profiling. And that could give you a nice summary of the data that you're working on. So it gives you, what are the characteristics, the statistical characteristics of the various tools. And what we've done is we just integrated it in the Q Sandbox so that it's readily available for you to use. So this is the data set we're working on. It tells you, how many zeros do you have, how are you actually using the various data sets. And it also gives you some other characteristics on the various variables which you're using as part of the features which are going to be used. And then there are some other tools. I think Google also has some tools you could potentially use. They have a tool called as Dive, and you could potentially bin various aspects to it, and you could create scatter plots, and you could label it, and you can choose different parameters, and then you can focus on the various aspects of the data set you're going to be using. And then there's also another tool Google has. It's called as Facets Overview, which is kind of a similar view of what pandas profiling does, but it kind of tells you like what are the different features you have in your training data set, what are the features you have in your test data set, how many of them are missing, what kind of values do you have. So this gives you an idea of what kind of data sets are available, and you can kind of customize it to whatever other tools you want to use, and that's where we have the toolbox. So if you have your own favorite data tool and you want to kind of either bring in some commercial data vendors, or you want to kind of build in your own tool, you can bring it in and then structure your audit use case associated with that. And then once you're done with your data review and you understand your data well, then comes the modeling piece. And in the modeling context, so here it was a very simplistic model. So we basically had sklearn, and we basically were using an open source implementation of a gradient boosting classifier. And the choice of modeling tools are many. You can use TensorFlow, you can use PyTorch, you can use anything which could potentially be built. Now, the one thing I liked was, and once we did a bunch of research, we found there are some open source tools available for building out model reports. And this was something we built, and this is an automatically generated report. So the way you would kind of build out this report, for example, so when I have my experiment, if you will, so this is the associated project. Now, when I want to create some kind of an experiment, so I have my experiment, and when I run it on my studio, so what we have is a studio environment to basically build and run different kinds of models. So here we are leveraging the Docker containers, which have basically encompassed all the requisite packages which are needed. And then we have set up various aspects to the model, what the environment is and what the key aspects are. So you can basically parameterize various things and look at the various aspects of the parameters so that you can build out your models. So when you execute these models, so each one of them goes in as a pipeline. So the auditor could potentially replicate these experiments and find out what are the various aspects of the models which were built. And in this particular case, you can see the history of the various experiments which are potentially built in here. And then once you execute these examples, come back in here. So you can basically look at the various tests which were done. And when you look at the report, you can basically generate, this is an automatically generated model card from the Google's specification, but then again, it could be customized in whatever way you want. And you can see the training data set, the evaluation data set, some of the ROC curves and the confusion matrices. So it gives the auditor the key data points which could be used for building out their analysis. And they could potentially customize it from there too. And then comes the environment card. I told you a little bit about the environment. So here you could potentially go in and you could structure the various environments you want to use. Here we have kind of set up different pipelines. So this was one pipeline I showed, but it could also be like a multi-stage pipeline. So I could have like a scraping environment, a data processing environment, an environment for synthetic or sentiment analysis. I could be calling different APIs. And each one of them could be its own Docker container with its own specific packages, and you can daisy chain the whole thing and schedule the various components so that you can start working with that. So once that environment is done, so you have the pipeline and you can review the pipeline. And then you could also do like an explainability analysis. And I found this explainability dashboard package pretty useful. So you could basically run your aspects, and then you could basically generate key metrics, aspects of confusion matrix, classification plots, precision plots, ROC curves, lift curves, cumulative precision. And again, the magic of open source is that most of these are readily available. It's just a question of you being able to be conversant with it and using it, and then you have individual predictions, have what if scenarios you could do like feature dependence. And this is where algorithmic auditing is actually going to be important, because many a times organizations do not have the requisite skill sets to basically understand not only the modeling capabilities, but also understanding what all goes into auditing a model in the first place. So that's where the field of algorithmic auditing is actually growing. A lot of consulting companies, a lot of organizations are bringing in experts who are familiar and comfortable evaluating these aspects, and then bringing in that expertise and being able to provide the qualified opinion based on the models they're going to be analyzing. And I was talking to an organization which has more than 50 data scientists, and most of them have PhDs. And for them, it may not be a big concern because they have the requisite skills in-house to be able to build out these methodologies and also build in the governance process and the auditing process internally. But I was also talking to another bank, which was a $100 million bank, and the model risk manager was responsible not only for taking care of the models, but also making decisions on which algorithms to source for various use cases. What do you use for sentiment analysis? What do you use for natural language processing? And many a times, even the evaluation becomes a challenge because of either bandwidth issues or knowledge issues. They said there's no way we can hire a PhD data scientist to come in and look at it because it's not that big in scope. And that's where they're being, trying to leverage experts outside of their email to kind of, bring in that perspective. But also in some ways, it's kind of bringing that independence aspect to it, wherein, you're not just building and evaluating it, but you're having a third party evaluating the robustness of the particular models. And then comes the fairness aspects to it. There are various fairness related packages out there. And this itself could be a whole lot. For example, the higher view and the pi metrics examples I gave you, the focus and the scope was predominantly looking at the fairness aspects of that. And then you could have findings, these are all my findings as you kind of build out the various aspects and then build out recommendations and build out the reporting infrastructure. But the key idea is, when you are thinking about leveraging, algorithmic audits as a part of your exercise, so you could basically think about what does it mean to build out an infrastructure which has the key elements which needs to be audited, and it could be internal. The audit need not be external always, but having the rigorous process to ensure that you are factoring in the key parts of the whole model building exercise will ensure that you are factoring in all the potential risks, but also creating a framework for adoption of responsible AI within the entity at the enterprise. So that's kind of a demo I wanted to share with you. If you're interested in having a look at the demo or providing your thoughts, please contact us. We are actively looking for people to try it out and give us feedback as we are building out the infrastructure. Oh, by the way, if you're taking the course, the Algorithmic Auditing course with Premier, which we are starting end of this month, we're going to give you access to some of these tooling so that you will be able to practice some of the things I'm kind of telling you in a live setting with a model so that you'll have the opportunity to kind of go through each one of these processes and understand the key parameters as you go through the various stages of building out an algorithmic auditing exercise. Okay, so that's a little bit of the demo. And I know we are kind of running short of time, so I'm gonna stop in here. And the slides which I presented will be available on q.academy. And if people are interested in joining us, just go to algoaudit.splashthat.com. And the classes start April 1st, and it's a 6-week course. And hope to see you all online. So I'm going to stop here and take questions. Please feel free to use the chat window or the Q&A window, and I'll be able to answer those questions for you possible. Okay, so I see a couple of questions. Okay, so I think there's a question about explainability. For explainability evaluation, what definition do you use for explainability? Any post hoc interpretability suffice explainability, which can be used for ex-ante prediction for using the trained model for new data sets without clear distinction between interpretability and explainability. user cannot assess the scope and the validity of the evaluation, especially for deep learning. It's lacking intuitive, inductive, and deductive formulation in the algorithmic architecture. Great point. Absolutely agree. And I think that's the reason why we had multiple speakers kind of talk about interpretability and explainability in the last many weeks. We had Ian, who is a protege of the University of Washington faculty, and they've been building a lot of different metrics, and he kind of provided an insightful talk on explainability. But then we also had Anupam from Truera, who has been building the whole framework on explainability. But also August presented multiple sessions on interpretable neural networks. So again, the key word is context. It's not about the way you define one of these terms, it's about context. It depends on the modeling methodology and what is feasible and what is possible in the context of what you're trying to do. If you're working with black boxes, and that's the visibility you will have, and you've made a choice of using these black boxes, you'll have to define like, well, I'm not able to get under the hood and understand what's actually happening. What are the means I should be using to make sure that if I'm able to interpret either the outcomes or understand how the model actually works, what are the key metrics I should be using? But then there could also be concerns about not understanding the underlying architectures. And there, again, the question would be, can we simplify enough so that we understand the underlying aspects and then interpret what's actually happening? So great points, but as I said, it all depends on the context. Another question, data sets are routinely divided into training and testing and developing machine learning models using machine learning. In the case of deciding cat or dog, some researchers initially use curated data sets, which include only key differentiators such as eyes, ears, mouth, and so forth. The evolutionary parallel is if there is a movement in forest, the individual must decide antelope or mountain lion in a fraction of a second. The visual system evolved for fast vision or slow detailed vision. I think it's a longer discussion, Sydney. The way I would kind of term it is, the traditional machine learning approach was feature engineering based, right? So we would basically spend a lot of time to understand the features associated with what would differentiate a cat versus a dog. And then we would look at feature importance, like, what are the key attributes which would be sufficient or which would be important to determine whether it's a cat or a dog. But as we have been, kind of leveraging deep learning and other computer vision techniques, we have kind of gone beyond just doing basic feature engineering. We are now providing a lot of data to these algorithms so that the algorithms themselves can understand the attributes of these images. And there, it may not define it as, a cat kind of an eye, or a cat kind of or a dog kind of an eye versus a cat kind of a nose versus a dog kind of a nose. It would probably be looking at features in the context of edges and lines and various other aspects which could be used as differentiator, different discriminative features for building out these algorithms. So that's where, if the data keeps changing or the domain keeps changing, then obviously the algorithm should consistently change to make sure that it retains the predictive accuracy and other metrics which you are going to be using for determining whether the models are actually useful. That's where the notion of drift and understanding where things could potentially go wrong are going to be important. Okay. So if there are any other questions, please feel free to type here. Otherwise, we will adjourn for the day. I hope you enjoyed today's session. And if there's any feedback or comments for today's session, please feel free to contact me. My email address is sri@university.com. I'd be happy to set up something if you're interested in looking at the demo or working on your use case in the context of algorithmic auditing. If there are no more questions, we will adjourn for the day, and we will meet you next time on the Quant University Lecture Series. Thank you.